Tonight, we're going to explore the half of the moon that no human eye has ever seen with its own gaze. Not hidden in some distant corner of the solar system. Not buried behind clouds of gas or veils of dust. Right there, close enough to touch with a good telescope, and yet forever turned away. For as long as human beings have looked up at the night sky, one entire face of our closest companion has remained in total darkness to us. Not darkness of light, darkness of knowledge. And what waits on the other side of that silence is stranger than almost anyone realizes. Billions of years ago, something happened to that hidden hemisphere. Something violent. Something that left a scar so deep it could swallow entire mountain ranges and still have room left over. A wound carved into rock, older than complex life itself, older than oxygen in Earth's atmosphere, older than almost everything we consider ancient. But buried beneath that scar is a truth that rarely gets mentioned. A truth about how close the moon may have come to being torn apart before it ever became the calm, silver light that watches over your nights. Here's the thing most people don't realize. That hidden face isn't just visually different. It's acoustically different. It sits in a silence so complete, so untouched by human noise, that scientists believe it may be one of the last quiet places left anywhere near Earth. No radio static, no signal interference, no trace of us at all. And in that silence, something extraordinary becomes possible. The chance to listen backward in time, toward the very first whispers of the universe itself. By the end of tonight, you're going to understand exactly why this hidden hemisphere still holds mysteries no human has ever witnessed firsthand. Why only machines have ever stood there. Why seeds once grew in that silence, far from any human hand. And why, even after more than 60 years of exploration, that face still waits in the dark, patient, unseen, keeping secrets older than the earth beneath your feet. Before we get started, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It's a simple action, but it helps this channel reach more curious minds, like yours. Now let's begin. Let's go back. Back before satellites, back before rockets, back to a time when the moon was simply a light in the dark, watched by every civilization that ever lived beneath it. And in all of that time, across every culture, every language, every pair of eyes that ever turned upward, one thing remained true without exception. Everyone saw the same face, every single time. Think about that for a moment. You have seen the moon your entire life. So did your parents, so did their parents, and their parents before them, stretching back through generation after generation, all the way to the very first humans who ever looked up and wondered what that pale light might be. And every one of them, without knowing it, was looking at the exact same hemisphere, the exact same seas of ancient lava, the exact same craters, the exact same shadows, arranged the exact same way. Not because anyone chose to look at that side, but because there was no other side available to see. Here's the thing most people don't realize. The moon does rotate. It is not frozen in place. It spins on its axis slowly, steadily, the same way Earth does. But something strange happens when you actually watch it happen. The moon takes about 27 days to rotate once on its axis, and it takes almost exactly that same amount of time to complete one full orbit around Earth. Two completely different motions, one spinning, one circling, and yet they move in perfect, silent agreement with each other. The result is a kind of cosmic stillness. As the moon travels around us, it turns just enough, at just the right pace, to always show us the same face. Never more, never less, always the same. Imagine standing in one spot in a room, slowly walking in a circle around a friend standing in the center. If you turn your body just enough as you walk, so that you're always facing them, they will only ever see your face, never the back of your head. Not because you're avoiding it, simply because your motion and your position are locked together, step for step, in a rhythm neither of you controls. That is what the moon has been doing to Earth for longer than human beings have existed to notice it. Scientists call this tidal locking, and it did not happen by accident. Billions of years ago, when the moon was young and still cooling from its violent birth, it did not move this way. It spun more freely then. Its orientation to Earth shifted, turned, wobbled, but Earth's gravity never stopped pulling at it. Slowly, relentlessly, across hundreds of millions of years, that pull dragged at the moon's shape, tugging at its rock, slowing its spin degree by degree until the two motions fell into step. Once locked, they stayed locked. A silent agreement written into the physics of two worlds, bound together by gravity, sealed long before anything resembling a human being ever existed to look up and wonder. And so, for all of recorded history, we only ever knew one face of our closest neighbour in space. Ancient astronomers charted its seas of dark stone, believing them to be actual oceans. They gave those dark patches names in Latin, calling them Maria, the word for seas, even though there was never a single drop of water in any of them. They tracked the pattern of light and shadow across that one visible face so precisely that early calendars and religious festivals were built around its rhythm. Entire civilizations organized their planting seasons, their ceremonies, their sense of time itself, around a face that never changed, never rotated away, never revealed anything new. But here is the quiet, strange truth buried underneath all of that familiarity. While every human being who ever lived was memorizing the same patterns on the same visible face, an entire second hemisphere existed just beyond view, turned away, permanently hidden. Not by distance, not by darkness, simply by the geometry of two worlds locked in an ancient, silent dance. That hidden hemisphere was there the whole time. It watched the sun rise and set across its own alien landscape, completely unseen by any living eye on Earth. It carried its own scars, its own mountains, its own untouched history. And no one, not a single astronomer, not a single storyteller, not a single dreamer staring upward through a telescope, had any way of knowing what it looked like. You have to sit with that for a second. For the entire span of human civilization, from the earliest firelit nights to the invention of writing, to the construction of pyramids and cathedrals and cities that rose and fell and rose again, half of our closest neighbour simply did not exist to us. Not because it was too far away. It orbits closer to us than almost anything else in the solar system. It was hidden by nothing more than the quiet, patient rules of gravity, locked into place before the first cell of life ever divided on Earth. And it would stay that way, century after century, empire after empire, until remarkably recently in the story of our species, something changed. Not the moon. The moon never changed its rhythm at all. What changed was us, our reach, our machines, our willingness to send something out beyond the sky, to look at what human eyes alone could never see. That moment did not come gently. It came suddenly, almost violently fast in the middle of a century defined by rivalry and ambition. And when it finally happened, when the first glimpse of that hidden face finally reached human hands, it revealed something that no ancient astronomer, no myth, no legend had ever prepared anyone to expect. To understand what came next, you have to understand something deeper about how that lock between Earth and the moon actually formed. Not just that it happened, but why gravity would ever bother arranging two worlds this way in the first place. The answer lies in something almost nobody thinks about when they look up at the night sky. The moon is not perfectly round, and that single, quiet imperfection changed everything. When the moon was young, still glowing from the heat of its own violent formation, it was slightly egg-shaped rather than a perfect sphere. A small bulge of extra mass sat on one side, subtle, almost unnoticeable, but enough. Earth's gravity, always reaching outward, found that bulge and began to pull on it. Not evenly, not gently. It pulled harder on the near side of that bulge than the far side, the same way gravity pulls harder on your feet than your head when you stand on a planet's surface. That small difference in pull created a kind of invisible leash, and every time the moon's rotation tried to carry that bulge away, Earth's gravity tugged it back. Here's the thing most people don't realize. This kind of gravitational pull creates friction, even across the emptiness of space. Not friction, like rubbing your hands together. Friction inside the rock itself, deep within the moon's body, as gravity flexed and stretched its interior with every rotation. That flexing generated heat. It also drained energy from the moon's spin. Slowly, patiently, the way water wears down stone given enough time. Every single rotation lost a little more energy than the last, and a spinning body that keeps losing energy can only do one thing: slow down. Picture a figure skater spinning with her arms outstretched, gradually slowing as friction and air resistance drain her momentum. Now imagine that slowing process stretched across hundreds of millions of years, not seconds, acting not on a human body, but on an entire world made of rock. That is closer to what happened to the moon. Its rotation didn't stop all at once. It bled away gradually, orbit after ancient orbit, until the spin finally slowed to match the rhythm of its journey around Earth. And once that match was made, something remarkable happened. The bulge that had been the cause of all this gravitational tugging finally settled into a permanent position, facing Earth directly, always. Not because the moon chose it, because physics simply stopped fighting itself at that exact alignment. The pull of gravity and the spin of the moon reached a kind of exhausted agreement, and once reached, there was nothing left to break it. No force remained to nudge the moon back out of that lock. It was permanent. It is permanent still at this very moment, as you listen to this in the dark. There is something almost unsettling about how quiet this process was. No explosion marked the moment tidal locking finished. No signal, no flash of light, nothing a distant observer could have pointed to and said, "There, that is when it happened." It simply concluded silently, the way certain kinds of agreements are never announced but are nonetheless absolute. Millions of years of gravitational negotiation, ending not with the event, but with a stillness that has now lasted for the majority of the moon's entire existence. Scientists have found something else buried within this story, something that adds another layer to the mystery. Deep beneath the moon's surface, on the near side, there are unusually dense regions of rock, concentrations of mass far heavier than the material surrounding them. Researchers call these mascons, short for mass concentrations, and many of them sit beneath those ancient dark seas of lava that early astronomers once mistook for oceans. These hidden pockets of extra weight may have played their own quiet role in anchoring the moon's final orientation, adding just enough additional pull to help lock that near face permanently toward Earth. What this means is that the face you've always seen is not simply the result of chance. It is the product of an ancient, invisible negotiation between mass, gravity, and time, one that concluded with mathematical precision long before anything alive existed to appreciate it. Every crater you can trace with your eyes on a clear night, every dark, sweeping plain of old volcanic rock sits on the exact hemisphere that this gravitational agreement selected to always face us. Not the other side, never the other side, this one. And that raises an uncomfortable question, one that ancient civilizations could never have answered, no matter how carefully they studied the sky. If gravity so precisely arranged which face we would always see, what determined which face we would never see at all? What did that hidden hemisphere look like? Was it similar to the familiar one, marked by the same wide, dark seas and gentle craters? Or was it something else entirely, shaped by billions of years of exposure that no one on Earth had ever witnessed? For most of human history, that question had no answer. It couldn't have one. The lock that gravity had written into the moon's motion made certain of that, sealing away half of our nearest neighbour as completely as if it existed in another part of the universe altogether. Telescopes, no matter how powerful, no matter how carefully aimed, could do nothing to change the geometry of an orbit set in motion long before human eyes ever existed to look through a lens. It would take something else, not a better telescope, not a longer night of careful observation. It would take something capable of leaving Earth entirely, travelling out past the edge of what human eyes could reach, and looking back at what no one had ever seen before. And remarkably, that moment was closer than almost anyone alive at the time could have imagined. The year was 1959. The world was in the middle of a race, though not the kind measured in seconds or medals. This was a race measured in altitude, in distance, in how far a nation could reach beyond the atmosphere before anyone else. Two rival powers, each determined to prove something about human capability, were hurling metal into the sky as fast as engineering would allow. And in the middle of that fierce competition, one particular ambition quietly took shape. Not simply to reach the moon, but to see what no human being had ever seen at all. The spacecraft built for this task was called Luna 3. It was not large. It was not especially advanced by later standards. Its equipment was delicate, almost primitive compared to what would follow in later decades. Built from photographic film, mirrors, and a processing system that had to develop images automatically without a single human hand nearby to guide it. Everything had to work correctly on the first attempt, millions of miles from anyone who could fix it if something failed. There would be no second chance to capture what it was sent to find. Here's the thing most people don't realize about that mission. The spacecraft could not simply point a camera and hope for the best. Its trajectory had to be calculated with extraordinary precision, curving around the moon at just the right angle, at just the right distance, so that its onboard camera would face the hidden hemisphere at the exact moment it passed behind. Too far off course and it would capture nothing but empty darkness. Too close and it risked colliding with the very world it was trying to photograph. Every variable had to align: gravity, timing, distance, direction, in a single narrow window that would never repeat. And then in October of that year, it happened. The spacecraft swept around the far side of the moon, cameras active, capturing images of a hemisphere that had remained completely invisible to every human being who had ever lived, not glimpsed, not partially observed, completely unseen for the entire span of human history until that exact moment. The film inside the spacecraft recorded what its cameras saw, developed itself using an automated onboard process, and then transmitted faint, grainy signals back across the vast distance separating it from Earth. The images that arrived were far from perfect. They were blurry, marked with static, streaked with interference from the long journey the signal had to travel. Scientists receiving the data on Earth had to work carefully just to make sense of the shapes hidden within the noise. But even through that imperfect transmission, something extraordinary became clear almost immediately. The hidden hemisphere did not look like the familiar face humanity had studied for thousands of years. It was different. Strikingly, undeniably different. Think about what that moment must have felt like. For every generation before this one, the moon had been a fixed familiar presence, its dark seas and pale highlands memorized by poets, sailors, farmers, and astronomers alike. And now, in a single transmission, that comfortable familiarity fractured just slightly. There was more to the moon than anyone had ever been allowed to see, an entire second identity, hidden the whole time behind the one everybody knew, patiently waiting for the technology to catch up with human curiosity. The scientists studying those first grainy images noticed something almost immediately that deepened the mystery rather than resolving it. Where the familiar near side showed wide, dark, smooth plains of ancient volcanic rock, the hidden far side appeared far rougher, far more cratered, far less marked by those dark seas that had defined the moon's appearance for all of recorded history. It was as if two entirely different processes had shaped each hemisphere, as if the moon itself carried two separate stories written into its surface, one facing us and one facing only the emptiness of space. This discovery did not answer the mystery. If anything, it deepened it considerably. Why would one half of a single unified world look so fundamentally different from the other? What could possibly explain such a stark divide, carved into a single sphere of rock spinning quietly through space? No one in 1959 had a complete answer. The images had opened a door, but what lay beyond that door would take decades of additional missions, additional data, and additional careful analysis to even begin to understand. Still, the achievement itself was staggering, regardless of the questions it left unanswered. For the first time since the Moon and Earth had settled into their ancient gravitational agreement, something had broken the silence between them. A hemisphere that had remained utterly hidden for the entire existence of human civilization had finally been witnessed, however imperfectly, however briefly. It marked one of those rare instances in history where a single transmission of blurry, static-filled images fundamentally changed what human beings understood about their closest neighbour in space. Word of the achievement spread quickly. Newspapers around the world published the grainy photographs, reproducing the strange, unfamiliar landscape for millions of readers who had grown up believing they already knew everything the moon had to offer. Astronomers pored over every visible detail, mapping craters and ridges that had never before appeared on any chart. Scientists began assigning names to prominent features on this new landscape, formally acknowledging, for the first time in recorded history, that the far side of the moon was not simply an empty concept. It was a real place, a place with mountains, craters, and terrain of its own. But those first images, however historic, were only the beginning. They were blurry sketches of a landscape that would take years of further missions to properly understand. Later spacecraft, equipped with better cameras and clearer optics, would return to study that hidden hemisphere in far greater detail, revealing textures and formations the original Lunar 3 images could only hint at. What those later missions found would confirm something the earliest photographs had merely suggested. This hidden world truly was different in ways that would eventually challenge scientists' basic assumptions about how the moon itself had formed. As better images slowly accumulated in the years following that first blurry transmission, a clearer picture began to emerge, and the more detail scientists gathered, the stranger the hidden hemisphere seemed to become. This was not simply a rougher version of the familiar near side. It was something closer to an entirely separate landscape, bearing only a distant resemblance to the moon most people believed they knew. Two faces of a single world, and yet somehow two completely different stories written across their surfaces. Consider the most obvious difference first, the one that struck early researchers immediately. The near side of the moon, the one visible from Earth every single night, is marked by wide, dark plains that stretch for hundreds of miles in places, smooth expanses of ancient volcanic rock formed when molten lava once flowed freely across the surface and cooled into flat, dark basins. These are the same features early astronomers mistook for oceans, giving them names like the Sea of Tranquility and the Sea of Serenity, poetic titles for landscapes that never held a single drop of water. On the far side, those same dark seas are almost entirely missing. Think about that contrast for a moment. On the face, you have looked at your entire life. Dark volcanic plains cover roughly a third of the visible surface, unmistakable even to the naked eye on a clear night. On the hidden hemisphere, that same kind of dark terrain covers barely a sliver of the landscape, a few scattered patches instead of vast connected seas. It is as if someone took a single canvas, painted one half generously with dark flowing colour, and left the other half almost untouched, pale and bare by comparison. Instead of those smooth dark plains, the far side is dominated by something else entirely. Endless highlands, pale, ancient, heavily cratered terrain that stretches in every direction, one impact scar overlapping another, layered across billions of years of cosmic bombardment with almost nothing to soften or smooth the record. Where the near side tells a story of ancient lava calming and filling in old wounds, the far side tells a story of exposure, of endless collision after endless collision, left largely undisguised for anyone who might eventually be able to see it. Here's the thing most people don't realize about those highlands. They are not simply cratered because more impacts happened there. Every part of the moon has been struck by countless objects across its long history, the near side included. The real difference lies deeper in the crust itself. Scientists studying the far side have found that its outer layer of rock is considerably thicker than the crust on the near side, in some regions more than doubled in depth. And that difference in thickness may explain almost everything about why these two hemispheres look so completely unlike one another. Imagine two ceramic bowls, one made with thin, delicate walls and the other built thick and heavy. Strike both with the same amount of force, and the thin-walled bowl is far more likely to crack all the way through, allowing whatever is inside to seep out and spread across the surface. The thick-walled bowl might show the impact, a dent, a fracture, but nothing escapes from within. That is roughly what happened across the moon billions of years ago, as ancient impacts struck both hemispheres. On the near side, with its thinner crust, many of those impacts broke all the way through to deep molten rock underneath, allowing lava to flow upward and fill the resulting basins, smoothing them into those dark, flat seas we still recognize today. On the thicker far side, that same kind of breakthrough rarely happened. The impacts left craters, but the lava beneath rarely found a path to the surface. The wounds simply stayed open, exposed, and pale. This single structural difference cascades into almost every other distinction between the two hemispheres. The far side is not only more heavily cratered and less covered in dark volcanic plains. Its terrain also sits, on average, at a noticeably higher elevation than the near side, its mountains and highlands rising further above the moon's overall centre of mass. Certain regions on the far side reach altitudes higher than anything found on the visible hemisphere. Jagged, ancient landscapes shaped entirely by impact rather than smoothed by flowing stone. And scattered across those highlands sits something else, something that early researchers could only begin to appreciate as imaging technology slowly improved across the decades following Luna 3. An impact scar so immense, so deep, so ancient, that it would eventually be recognized as one of the largest and oldest preserved craters anywhere in the solar system. At first, scientists could only see fragments of it, pieces of a puzzle far larger than any single photograph could capture. It would take years of additional missions, additional data, and increasingly sophisticated instruments before the true scale of that scar could finally be understood. But even in those early years, working only with rough, developing images, one thing had already become impossible to ignore. This was not simply one moon with two slightly different sides. This was, in almost every meaningful way, two different worlds sharing a single orbit, a single gravitational lock, a single ancient history, and yet shaped by entirely different forces across billions of years of silent, undocumented time. And that raised a question, far larger than anything the earliest photographs alone could answer. What could possibly explain a divide this fundamental, carved so deeply into a single sphere of rock? The answer, when it finally came, would reach back to the very earliest, most violent days of the moon's existence. The difference in crust thickness explained a great deal, but it did not explain everything. Scientists studying the moon in the decades after those first grainy photographs kept returning to a deeper, more uncomfortable question. Why would the crust itself be thicker on one side and thinner on the other in the first place? A world that formed from a single collapsing cloud of molten rock should, in theory, cool and solidify in roughly the same way all the way around its surface, and yet it clearly hadn't. Something, long ago, had treated these two hemispheres completely differently. One leading explanation reaches back to the earliest days of the moon's existence, when it was not yet the cold, solid world you picture in the night sky, but an ocean. Not an ocean of water, an ocean of molten rock, an entire outer layer of liquid stone, hundreds of miles deep, glowing at temperatures that would vaporize almost anything instantly. During this period, Earth itself was also newly formed, and far closer to the moon than it is today, radiating enormous heat outward into space. Some researchers believe that heat, pouring across the short distance separating the two worlds, kept the moon's near-side magma ocean liquid for far longer than the far side, which faced only the cold emptiness of space. Here's the thing, most people don't realise about that idea. A magma ocean that stays liquid longer cools more slowly, and slower cooling changes which minerals have time to form and settle before everything hardens into solid crust. On the far side, cooling faster and losing heat more quickly to the surrounding darkness, the crust may have solidified sooner, trapping in place a thicker, heavier layer of rock before it had the chance to settle and thin the way the near side eventually did. Two hemispheres, cooling at two different rates, produced by nothing more than one side facing a warm, young Earth, and the other facing nothing at all. But heat from a nearby planet is not the only theory scientists have proposed. There is another idea, considerably stranger, that has gained serious attention among researchers studying this asymmetry. It begins not with heat, but with a second moon, a companion world smaller than the moon you know, that may have formed alongside it, born from the very same violent collision that created the moon itself billions of years ago. According to this theory, two bodies emerged from that ancient chaos rather than one, briefly orbiting Earth together, trapped in the same region of space by the same gravitational forces. For a time, perhaps a few tens of millions of years, this smaller companion may have simply coexisted alongside the larger moon, following a stable orbit nearby. But stable is a fragile word when applied to two bodies sharing such a tight gravitational space. Eventually, something shifted, and when it did, the smaller companion had nowhere left to go but toward its larger twin. Imagine for a moment watching that event unfold from a safe distance, not the sudden violent flash of a high-speed collision, the kind that shatters worlds and sends debris scattering across the solar system. Researchers who support this theory believe the impact happened slowly by cosmic standards, at a relatively gentle speed, the smaller body essentially settling into the larger one, rather than exploding against it. Slow enough that instead of carving out a massive new crater, the smaller moon's material spread out across the surface it struck, piling up gradually, layer upon layer, like a splatter of thick paint frozen the moment it hit a canvas. And where did that ancient collision strike? According to this theory, it struck what is now the far side, adding an entire additional layer of solid material directly onto crust that may have already been slightly thicker than the near side to begin with. Layer stacked upon layer, one ancient collision compounding an existing imbalance, until the far side's crust grew thick enough to explain nearly everything researchers have measured. Its unusual depth, its highland-dominated terrain, its striking scarcity of the dark volcanic seas that define the opposite hemisphere. This idea remains a theory, not a settled fact. Scientists continue debating it, testing it against new data gathered from subsequent lunar missions, comparing its predictions to the chemical makeup of far-side rock samples whenever they become available. Some evidence supports it strongly. Certain unusual mineral concentrations found in far-side terrain seem consistent with material that did not originate from the moon's own primary formation, hinting at an outside source, exactly as this theory predicts. Other evidence remains ambiguous, open to competing interpretations that scientists have not yet fully resolved. But consider what this theory suggests. Even in its most uncertain form, it suggests that the version of the moon you have looked up at your entire life may not be a single, unified world at all. It may be the survivor of an ancient merger, one body absorbing another so long ago that almost no visible trace of the smaller moon remains today, except in the shape, thickness, and strange cratered highlands of the very hemisphere you have never once seen with your own eyes. Think about what that means. Every time you have gazed up at that familiar, pale light, that comfortable, unchanging face humanity has known since before written language existed, you may have been looking at only half of a story. The other half, quite possibly the remains of another moon entirely, sits permanently turned away, carrying inside its very structure the memory of a collision more ancient than nearly anything else in the solar system's recorded history. And within that same hidden hemisphere lies still more evidence of ancient violence, scars from impacts so massive, so consequential, that they would eventually force scientists to reconsider not just how the moon's two faces came to differ, but how close the entire moon may have once come to being destroyed altogether. Somewhere within that thick, ancient, cratered terrain of the far side lies a wound so large that early researchers, working only with blurry photographs and incomplete data, could barely comprehend its true scale. It would take decades of additional missions, improved cameras, and careful mapping before scientists finally understood exactly what they were looking at. And when they did, the numbers involved were almost impossible to hold in your mind all at once. It is called the South Pole Aitken Basin, named for the two lunar landmarks that mark its opposite edges. And to call it simply a crater feels almost inadequate, the way calling the ocean simply a puddle would feel inadequate. This is not a small tidy circle punched into the surface. It is an immense, sprawling depression, stretching across a significant portion of the moon's entire far side, so vast that its full outline is difficult to appreciate from the ground, only becoming truly clear when viewed from orbit, or better yet, mapped using data collected over multiple missions across many years. Consider its size for a moment, because numbers like this deserve to be sat with rather than rushed past. The South Pole Aitken Basin stretches across roughly 1,550 miles at its widest point. To put that into perspective, that is a distance roughly equivalent to travelling from one end of a large continent to the other, except this entire distance sits within a single, connected impact scar. It ranks among the largest confirmed impact craters anywhere in the solar system, rivaling similar ancient scars found on other worlds like Mars. And in terms of sheer surface area, few known craters anywhere come close to matching it. Now consider its depth, because the scale only becomes more staggering from there. In its deepest regions, the basin plunges roughly 5 miles below the surrounding lunar surface, 5 miles down into solid, ancient rock. If you try to imagine standing at its lowest point and looking upward toward its rim, you would be looking up at cliffs and slopes rising higher than most mountain ranges found anywhere on Earth. This is not a shallow depression. It is one of the deepest, most dramatic features found on any rocky world humans have ever studied in this much detail. Here's the thing most people don't realize about a crater this size. It did not form from an ordinary impact, the kind that has peppered the moon's surface countless times across billions of years. A crater of this scale requires something almost unimaginably violent, an object massive enough, moving fast enough, to punch through crust that was already, as you now know, considerably thicker on this hemisphere than on the near side. Whatever struck the moon to create this basin was not a small fragment of space debris. It was something closer to a small world in its own right. Scientists estimate that the object responsible for this impact was likely tens of miles across, moving at speeds that are difficult to translate into anything resembling everyday experience, speeds fast enough that the moment of impact would have released energy on a scale that dwarfs nearly every catastrophe in recorded human history combined, many times over, in a single instant. Rock vaporized instantly. Solid stone, for a brief moment, behaved more like liquid, rippling outward from the point of impact the way water ripples from a stone thrown into a still pond, except here the ripples were mountains and the pond was solid ground. Think about what that means for the moon as a whole. This was not a wound confined to one small region. An impact of this magnitude would have sent shockwaves rippling through the moon's entire structure, its effects reaching deep beneath the surface, potentially disturbing material far below the crust itself. Some researchers believe the impact may have been powerful enough to bring material up from deep within the moon's interior, material that had never before been exposed on the surface, material that had remained buried since the moon's earliest formation. And this is where the story becomes almost eerie in its implications. If that theory holds true, then the South Pole Aitken Basin may offer something scientists rarely have access to anywhere in the solar system. A genuine window into the deep interior of a rocky world, exposed not through careful excavation, but through violent, ancient trauma. Material from far beneath the moon's outer shell, potentially unchanged for billions of years, sitting exposed on the surface of the one hemisphere that remained completely unseen by human eyes for the entirety of recorded history. But before scientists could properly study what this ancient scar had revealed, they first needed to understand something even more fundamental. When did this happen? How long ago did an object large enough to create a wound this size strike the moon, with enough force to reshape an entire hemisphere? The answer, when researchers finally calculated it, reached back to a period so early in the moon's existence that it forced a reconsideration of just how violent and how vulnerable the young moon truly was. To answer that question, scientists had to look at the basin's edges, its layers, and the composition of rock scattered across the surrounding highlands. Every impact leaves behind clues, fragments of melted stone that cooled and hardened at a specific moment, chemical signatures that act almost like a fingerprint left at the scene of an ancient catastrophe. By studying these clues, carefully, patiently, across decades of analysis, researchers began to piece together a rough timeline for when this immense collision actually occurred. And that timeline reached back further than almost anyone expected. The best current estimates place this impact somewhere between 4 billion and 4.3 billion years ago. Let that number settle for a moment. The moon itself is believed to have formed roughly 4.5 billion years ago, meaning this catastrophic collision struck within the first few hundred million years of its entire existence. In the grand span of the moon's 4.5 billion year history, this wound was carved almost at the very beginning, while the moon itself was still, in a sense, young, still settling, still finding its shape. This period in solar system history has a name among scientists, one that hints at just how chaotic those early years truly were. Some researchers refer to it as part of an era of intense bombardment, a stretch of time when the young solar system was still cluttered with leftover debris from its own formation. Asteroids, fragments of failed planets, chunks of rock and ice, tens of miles across still drifting through the inner solar system, not yet swept up into stable orbits or pulled into the planets and moons that would eventually claim them. Earth endured this bombardment too. So did Mars. So did nearly every solid surface in the young solar system. But the moon, lacking any atmosphere to burn up incoming debris, lacking any ocean to swallow the evidence, preserved these ancient scars in a way few other worlds ever could. Here's the thing most people don't realize about an impact this size, striking a world this young. The moon at that time had not yet fully solidified throughout its interior. Deep beneath its crust, significant portions of its structure may still have been partially molten, still cooling from its explosive birth. An impact powerful enough to gouge out a basin 1,550 miles wide, did not simply scar the surface. It sent shockwaves reverberating through a world that was, in some very real sense, still soft, still vulnerable, still finding its final solid form. Some researchers have gone so far as to model just how close this impact came to fundamentally altering the moon's structure, or even threatening its overall stability. An object large enough and fast enough to carve a wound this deep, striking a world still cooling from its own formation, sits uncomfortably close to a threshold where an impact stops merely cratering a surface and starts genuinely reshaping, or even partially disassembling, the body it strikes. The moon, by every indication available to scientists today, survived this collision intact. But intact does not mean unaffected. It means the impact fell just short of catastrophic, close enough to leave permanent, planet-scale evidence of just how violent that encounter truly was. Think about the raw physics involved for a moment, because it helps to make sense of just how narrow that margin really was. An impact of this scale would have released energy equivalent to detonating explosive forces, almost impossible to translate into any familiar comparison, concentrated into a single, instantaneous event. Rock at the point of impact would not simply have cracked or shattered. It would have been instantly converted to superheated vapor and molten spray, hurled outward and upward, some of it launched with enough force to briefly escape the moon's gravity entirely, only to fall back to the surface later as scattered debris across a huge portion of the far side. And here is where the story turns almost unsettling in its scope. Some of that debris, according to models developed by researchers studying this event, may have rained back down, not just locally, but across significant portions of the moon's surface, potentially even reaching areas well beyond the basin's immediate boundaries. An impact this large did not simply create a crater, it rearranged material across an enormous stretch of the moon's crust, redistributing rock and dust in ways that geologists are still working to fully untangle even now, billions of years later. Consider, too, what this event tells us about the era in which it occurred. This was not some unusual singular catastrophe unique to the moon alone. It was one especially dramatic example of a period when the entire inner solar system existed in a state of near constant violence, worlds forming and reshaping themselves through repeated devastating collisions, long before anything resembling stability, let alone life, could take hold anywhere nearby. The moon's far side, in this sense, stands as a kind of frozen record of that chaos, preserved in stone, undisturbed by weather or water, or the slow erosion that has erased similar scars from Earth's own surface over billions of years. And this is precisely why that ancient wound matters so much to scientists studying it today. Earth experienced impacts just as violent during this same early period. But Earth has an atmosphere, oceans, and active geological processes that have spent billions of years erasing almost every trace of its own ancient bombardment. The moon has none of these erasing forces. No wind, no rain, no shifting tectonic plates to fold ancient scars back into the interior. Whatever happened to the moon 4 billion years ago is still visible today, largely unchanged, sitting quietly on a hemisphere that no human being ever witnessed until less than a century ago. But a wound this size did more than simply reshape the moon's surface. It changed the very acoustics, the very atmosphere, the very silence of the world it left behind. Because carved into the deepest, most ancient scar on the entire moon lies something that would, many years later, capture the attention of scientists for reasons that have nothing to do with impacts at all, and everything to do with silence itself. Close your eyes for a moment and try to imagine true silence. Not the quiet of a still room at night, where a clock still ticks somewhere in the distance, where your own breathing still fills the air with faint sound. Not even the hush of a sealed chamber deep underground, where footsteps and heartbeats still echo faintly off stone walls. Try to imagine silence so complete that sound itself has nothing left to travel through at all. That is closer to what waits on the far side of the moon. Here's the thing most people don't realize about sound. It is not simply a matter of quiet versus loud. Sound needs something to move through, some medium of molecules close enough together to pass vibration from one to the next. The way a wave passes through water or a ripple travels along a stretched rope. On Earth, that medium is air, an ocean of gas surrounding you at every moment, carrying every whisper, every footstep, every distant thunderclap directly to your ears without you ever having to think about how it happens. Take away that air, and you do not simply lower the volume. You remove sound from existence entirely. The moon has no atmosphere, not a thin one, not a fragile, wispy one, clinging weakly to the surface. Essentially none at all, a vacuum so close to the emptiness of space itself that scientists sometimes describe the moon's surface conditions as barely distinguishable from open space. And this is true across the entire moon, both the familiar face you have always known and the hidden hemisphere turned permanently away. But on the far side, this absence of air combines with something else, something almost unique in the story we have been building. Complete isolation. No air, no wind, no sound at all, not even the faintest whisper of vibration passing between molecules. Because there are no molecules there to carry it. Total silence. Not the temporary hush of a quiet Earth night, waiting to be broken at any moment by a car passing, a dog barking, wind moving through distant trees. A permanent, structural silence built directly into the physical conditions of that landscape, unbroken for as long as the moon has existed in its current form. Think about standing there if such a thing were somehow possible. Your own footsteps, striking ancient, dust-covered rock, would produce no sound whatsoever, no crunch, no scrape, nothing travelling to your ears except through the vibrations conducted directly through your own body. Even your own voice, if you tried to call out across that landscape, would travel nowhere beyond the inside of your own helmet. The vast cratered highlands, stretching toward every horizon, would remain utterly, permanently silent, regardless of what happened within them. No wind to stir the dust, no storms to roll across ancient craters. No sound at all, ever, under any circumstances, on a landscape shaped by billions of years of the most violent impacts in the moon's entire history. The very same collisions capable of gouging out a wound 1,550 miles wide would have occurred in complete, total silence. The impact's fury written entirely in light, heat, and shattered rock, but never in sound. Nothing to hear, nothing to carry the noise, just devastating, silent violence, unfolding and then fading into stillness that has never once been broken since. And there is something almost impossible to reconcile in that image, an impact powerful enough to release energy beyond ordinary comprehension, an event capable of reshaping an entire hemisphere of a world, happening in complete, absolute silence. No roar, no thunder, no shockwave of sound rippling outward the way an explosion on Earth would announce itself for miles in every direction. Just silent, catastrophic transformation, witnessed by no one, heard by nothing, recorded only in the permanent scars left behind on stone. This silence is not confined to sound in the way you typically think about it. It extends into something even stranger, something that becomes important later in this story. The far side sits permanently shielded from something else that fills nearly every corner of near-Earth space without most people ever noticing it. A different kind of noise entirely. Not the kind carried by air, the kind carried by radio waves, invisible signals crisscrossing space constantly, generated by human technology on a scale almost impossible to fully appreciate. Here on Earth, and even on the familiar near side of the moon, this kind of noise never fully disappears. Radio transmissions, generated by television broadcasts, communication satellites, cell networks, and countless other sources spread outward constantly, filling the space around our planet with a faint but persistent hum of interference. It is invisible. It is silent to human ears. But to sensitive scientific instruments, it registers as a kind of unavoidable static, a background clutter that exists almost everywhere near Earth, seeping into nearly every direction human technology can reach. The hidden hemisphere of the Moon experiences something different. Because of its permanent orientation, facing forever away from Earth, it sits shielded not just from sunlight during certain phases, and not just from atmosphere in the way every part of the Moon lacks air. It sits shielded from an entire ocean of human-generated radio noise that blankets nearly every other accessible location near our planet. An entire 2,000-mile-wide stretch of ancient, cratered terrain, permanently silent in every sense of the word, untouched by sound, and remarkably untouched by the electronic noise of human civilization as well. And it is this second kind of silence, the radio silence rather than the acoustic one, that would eventually capture the imagination of scientists in ways that reached far beyond simple curiosity about a quiet, empty landscape. Because a place shielded from every trace of human interference offers something almost nowhere else in the solar system can provide: the chance to listen for something else entirely, something far older, something that might still be echoing faintly from the very beginning of the universe itself. To understand exactly how remarkable this radio silence truly is, you first have to understand just how loud Earth actually is, in ways no human ear could ever detect. Not loud in the sense of sound travelling through air, loud in an entirely different sense, an electromagnetic sense, a constant outpouring of energy that has been building steadily for less than a century, yet has already transformed the space surrounding our planet into something almost unrecognisable compared to the quiet emptiness that existed before. Every television broadcast, every radio station, every cell phone conversation, every satellite transmission, every radar signal bouncing between ships, airplanes, and military installations. All of it radiates outward from Earth, constantly, in every direction, at the speed of light, spreading endlessly into space whether anyone intended it to or not. This has been happening for less than 100 years, a blink of an eye compared to the Moon's 4.5 billion year history, and yet in that short span, human civilization has filled the space around our planet with a dense, ever-present fog of radio noise unlike anything that existed here before. Here's the thing. Most people don't realise about this noise. It does not simply fade away once it leaves Earth's atmosphere. It keeps travelling, weakening gradually with distance but never fully disappearing, spreading outward in an ever-expanding sphere that, by now, stretches many light years into space, carrying faint echoes of decades-old broadcasts towards stars no human being has ever visited. Anywhere near Earth, on Earth's surface, in orbit around it, even on the familiar near side of the Moon, this noise remains detectable, an inescapable electronic hum layered over everything scientists try to observe. And this creates a serious problem for anyone hoping to study the faintest, most delicate signals the universe has to offer. Imagine trying to hear someone whisper from across a room while a crowd around you shouts at the top of their lungs. No matter how good your hearing is, no matter how sensitive your equipment might be, that whisper simply cannot compete with the noise surrounding it. This is, essentially, the challenge facing radio astronomers here on Earth, and even in orbit around it. The universe whispers constantly, in signals so faint they make the quietest whisper seem thunderous by comparison. And human civilization, however unintentionally, has been shouting over that whisper for the better part of a century. The far side of the Moon changes this equation entirely. Because of its permanent orientation forever facing away from Earth, an entire 2,000-mile wide barrier of solid rock sits directly between that hidden hemisphere and every single source of radio noise our planet produces. Not a partial barrier, not a barrier that occasionally lets some interference slip through depending on atmospheric conditions or time of day. A complete, permanent, physical shield blocking every trace of Earth's electronic noise before it can ever reach that hidden terrain. Think about the scale of that isolation for a moment. It is not simply quieter there than on Earth. It may be quieter there in the specific frequencies scientists care most about than almost anywhere else easily reachable in the entire solar system. Even spacecraft sent far out into deep space, well beyond the moon's orbit, still receive faint traces of Earth's radio noise, arriving from a direction their instruments cannot fully block. The far side of the moon, uniquely, sits behind a natural barrier massive enough and positioned precisely enough to block that noise almost entirely, using nothing but solid rock and simple geometry. This is where the story becomes almost unsettling in its implications, in the same quiet way so much of this hidden hemisphere's story has been. Consider what it means for an entire portion of a nearby world to remain permanently, structurally isolated from every signal generated by human civilization, forever, for as long as the moon continues its current orbit. No television broadcasts have ever reached it. No radio programs, no satellite transmissions, no military radar signals, nothing generated by human hands has ever touched that hidden terrain, and by the very geometry of the moon's tidal lock, nothing generated by human hands ever will. Not directly, not without deliberately routing a signal around or through the moon itself. It is a strange thing to consider. An entire hemisphere, closer to Earth than almost anything else in the solar system, permanently untouched by the voice of human civilization. Every signal we have ever broadcast into space, every transmission carrying decades of television programs, news broadcasts, and casual conversation, has spread outward toward distant stars, yet has never once, and will never, directly reach that quiet, cratered landscape sitting just on the other side of the moon. Not because the distance is too great, because the moon itself stands permanently in the way, an ancient, silent wall between Earth's endless electronic chatter and one of the last truly radio-quiet places accessible to human technology. And this rare kind of isolation is precisely why, decades after those first grainy photographs revealed the far side's existence, scientists began looking at that hidden hemisphere with an entirely new kind of interest. Not simply as a landscape to map, or a mystery to explain through ancient collisions and gravitational locks, but as a listening post, a place quiet enough, shielded enough, isolated enough to potentially detect something that has been almost impossible to hear anywhere else near Earth. Something that may still be echoing, faintly, from a period so early in the universe's history that almost nothing else remains to tell its story. To understand what scientists are actually hoping to hear from that silent hemisphere, you have to go back much further than the moon itself, further than Earth, further than the sun. Back to a period so early in the universe's history that stars as you picture them, twinkling points of light scattered across the darkness, did not yet exist anywhere at all. This was a time cosmologists sometimes call the cosmic dark ages, a stretch of hundreds of millions of years following the birth of the universe when nothing shone. No stars, no galaxies, just vast cooling clouds of simple gas drifting silently through an expanding darkness. Here's the thing most people don't realize about that ancient period. Even though no light existed yet, the universe was not entirely without a voice. That primordial gas, mostly hydrogen, carried a faint signature, a subtle shift in energy that radio telescopes, if sensitive enough, might theoretically be able to detect even today, billions of years later. Scientists refer to this as the 21 centimeter signal, named for its specific wavelength, a whisper left over from a time before the first star ever ignited, still travelling across the universe, faint and ancient beyond easy comprehension. Think about what that signal actually represents. It is not simply old, it's a direct trace of the earliest structural moments of everything that exists. The very first hints of gas beginning to clump together under gravity's patient pull. The earliest stirrings that would eventually lead to the first stars, the first galaxies, and eventually, after billions of years of gradual assembly, to the Sun, to Earth, and to every single person who has ever lived. Detecting this signal clearly would mean, in a very real sense, listening to the universe's own childhood, a period so early that almost nothing else remains to describe it. But here is the frustrating problem scientists have faced for decades. This signal is extraordinarily faint. Faint in a way that is difficult to overstate, buried beneath billions of years of expansion and dilution, arriving at Earth so weakly that it competes directly with exactly the kind of radio noise generated constantly by human civilization. Television broadcasts, radio stations, satellite communications, all of it operates in frequency ranges that overlap uncomfortably closely with this ancient cosmic whisper, drowning it out almost everywhere near Earth, no matter how sensitive the listening equipment might be. And this is precisely why the far side of the moon has captured such serious attention among scientists studying this specific problem. Remember that permanent shield of solid rock, blocking every trace of Earth's electronic noise before it can ever reach that hidden terrain. A telescope built on that hemisphere would sit behind the only barrier in the accessible solar system capable of fully blocking humanity's own radio chatter, offering a chance to listen for this faint, ancient signal without competing against the very civilization trying to detect it. Imagine, for a moment, an enormous radio telescope, or perhaps a network of smaller antennas spread across the floor of an ancient crater on that far side, positioned deliberately within the deepest, most shielded regions of that hidden terrain. Some scientists have proposed exactly this, using the natural bowl shape of large craters as a kind of built-in support structure, reducing the need to construct elaborate frameworks the way similar telescopes require here on Earth. The moon itself, in this vision, becomes both the shield blocking interference and the foundation supporting the instrument. This is not simply an abstract idea confined to theoretical papers. Proposals for far-side radio observatories have been seriously studied by multiple space agencies over the past several decades, with growing interest as our technology has advanced enough to make such a project genuinely feasible rather than merely aspirational. Some designs envision robotic systems unrolling wire antennas across the lunar surface, systems capable of assembling themselves with minimal human intervention, given how difficult and expensive it would be to send astronauts to build something this delicate directly. But here is where the story deepens into something almost philosophically unsettling. If scientists ever succeed in building such an observatory, and ever succeed in clearly detecting this ancient 21-centimetre signal, they will be listening to something extraordinary. Not simply old data, a direct echo from a period roughly 13 billion years in the past, from an era before any star had ever formed, before any planet existed, before anything resembling structure or order had yet emerged from the universe's early, formless expansion. Think about what it means for that signal to exist at all, faint and ancient, still travelling silently across space after all this time, waiting for something sensitive enough and quiet enough to finally receive it clearly. And think about where scientists believe the best chance of finally hearing it clearly might exist. Not deep in interstellar space, far beyond anything human technology could easily reach. Right here, remarkably close to Earth, hidden behind the familiar silver light you have looked up at your entire life, on a hemisphere that remained completely unseen until less than a century ago. There is something almost poetic, and admittedly a little unsettling about that arrangement. For the entire span of human civilization, an object close enough to touch with a good telescope carried, hidden on its far side, one of the quietest, most promising locations anywhere accessible to us for listening to the very beginning of everything. Not distant, not difficult to reach in any absolute sense, simply turned away, patiently waiting for billions of years for technology capable of finally taking advantage of what its unique position in space has always offered. And reaching that hidden hemisphere to build anything at all would require solving a challenge unlike anything faced by earlier space missions. Because landing on the far side means landing somewhere that cannot see Earth directly. Not for a single moment, not from any point on its surface. Communicating with anything placed there would require a solution no earlier mission had ever needed to consider. And solving that exact problem would eventually fall to a mission that accomplished something no spacecraft from any nation had ever managed before. For nearly 60 years after those first blurry photographs revealed the far side's existence, every single spacecraft that had ever touched the moon's surface landed on the near side, the familiar hemisphere, the one always facing Earth. This was not a matter of preference, it was a matter of basic necessity. Every landing mission needed a way to communicate with controllers back on Earth, sending data, receiving instructions, confirming that systems were functioning correctly. And on the far side, permanently facing away, that kind of direct communication was simply impossible. No signal could travel in a straight line through 2,000 miles of solid rock. This single obstacle kept the far side effectively out of reach for any landing mission, no matter how advanced spacecraft technology became over the following decades. Photographs could be taken from orbit, passing briefly over that hidden terrain before swinging back around to a position where Earth was visible again. But actually landing something there and keeping it operational long enough to conduct meaningful science required solving a communication problem that no earlier mission had ever needed to address. You cannot simply talk to something that has an entire world blocking every possible line of sight back home. Here's the thing, most people don't realize about how this problem was eventually solved. The answer did not involve building a more powerful transmitter or somehow bending radio waves around solid rock. It involved position, a specific, carefully chosen point in space where gravity itself could be used to keep a relay satellite permanently stationed in exactly the right spot. This location, known as a Lagrange point, exists beyond the moon's far side, a place where the combined gravitational pull of Earth and Moon creates a stable position that a spacecraft can occupy with minimal fuel expenditure, remaining fixed there for years at a time. In the spring of 2018, China's space program launched a satellite named Kuekiao, meaning Magpie Bridge, a name drawn from an old folk tale about a bridge of birds connecting two separated lovers across a great celestial divide. The name proved remarkably fitting. This satellite's entire purpose was to serve as exactly that kind of bridge, positioned precisely at that stable point beyond the moon, able to see both the hidden far side and Earth simultaneously, relaying signals back and forth between a location no direct transmission could otherwise reach. With that bridge successfully established, the mission's true objective could finally proceed. Later that same year, China launched Chang'e 4, named after a moon goddess from ancient Chinese mythology, carrying a lander and a small rover toward a specific target within that ancient, cratered terrain you have already come to know well. Its destination was inside the South Pole Aitken Basin itself, the same immense, ancient scar carved by that catastrophic collision billions of years earlier, offering scientists a rare chance to study material from one of the oldest, most significant impact sites anywhere on the moon. Think about the layers of achievement stacked within this single mission. Not only would it need to navigate the extraordinary technical challenge of landing precisely within a specific, scientifically significant crater using only automated systems, since no direct real-time communication with Earth would be possible during the descent itself. It would also need to rely entirely on that relay satellite, quietly stationed in space, faithfully passing every signal back and forth across a distance, and an obstacle that had kept this entire hemisphere permanently out of reach for every previous space mission in history. In January of 2019, Chang'e 4 touched down successfully within the von Karman crater, itself a significant impact feature nested inside the larger South Pole Aitken Basin. For the first time in the entire history of space exploration, spanning missions from multiple nations across more than half a century, a spacecraft had successfully landed on the far side of the Moon. Not simply photographed it from orbit, not simply passed briefly overhead before swinging back toward a position with a clear view of Earth. Landed there, directly, on ground no human-made object had ever touched before. The images that followed captured something remarkable: ancient, cratered terrain stretching toward the horizon in every direction, pale and rugged, exactly the kind of highland landscape scientists had come to expect from decades of orbital photography, yet now visible in far greater ground-level detail than any previous mission had ever achieved. A small rover named U-22, after a mythical jade rabbit companion of the moon goddess, rolled slowly across that ancient surface, becoming the first wheeled vehicle from any nation to explore ground that had remained completely hidden from every civilization throughout the entirety of recorded human history. And this achievement carried significance well beyond simple national pride or technical accomplishment. It meant scientists could finally study, directly and in close detail, material from one of the oldest, most consequential impact events anywhere on the Moon, potentially confirming or challenging theories about its origin, its timing, and what it might reveal about the Moon's ancient interior. Every measurement taken, every sample of soil analysed, every photograph captured added genuine data to questions that had, until this moment, relied entirely on distant orbital observation and careful indirect inference. But among everything Chang'e 4 carried to that ancient, silent landscape, one particular experiment captured public attention in a way that went beyond scientific instruments and geological data entirely. Tucked within the lander's structure sat a small sealed container, holding something almost startlingly ordinary compared to everything else this mission represented: seeds. Simple, everyday seeds carried across the vast emptiness of space to a hemisphere that had never once, in all its billions of years of existence, supported anything resembling life. The container was small, roughly the size of a lunchbox, sealed tightly and insulated carefully against the extreme conditions waiting outside. Inside, scientists had packed a modest, carefully chosen collection of life. Cotton seeds, potato seeds, seeds from a small flowering plant commonly used in laboratory research, yeast, even fruit fly eggs, added to create a simple, self-contained ecosystem capable of testing something no one had ever directly examined before. Could ordinary life from Earth actually survive and even grow on the surface of another world? This was not simply a symbolic gesture, some poetic flourish added to an otherwise purely geological mission. It represented a genuine scientific question with serious long-term implications. If human beings ever hope to establish extended, self-sustaining presence beyond Earth, whether on the Moon or eventually on Mars, they will need to know whether basic biological systems, plants capable of producing food, oxygen, and organic material, can actually function somewhere so radically different from Earth's own protective environment. This small sealed container represented an early, modest attempt to begin answering that question directly, rather than simply theorizing about it from a laboratory back on Earth. Here's the thing most people don't realize about the conditions this experiment had to survive before it could even begin. The far side of the moon is not a gentle environment. Temperatures across a single lunar day, which lasts roughly 2 Earth weeks, swing to devastating extremes. During daylight, surface temperatures can climb past 200 degrees Fahrenheit, hot enough to damage sensitive biological material almost instantly, if left unprotected. During the long lunar night, equally lasting about 2 Earth weeks, temperatures plunge to nearly 280 degrees below zero, cold enough to freeze nearly anything solid within moments of exposure. To survive this, the small container carrying these seeds included its own miniature climate control system, carefully regulating temperature, releasing water at precisely timed intervals, and allowing natural light to filter in through a tube connected to the surface above. Everything had to function automatically, without any possibility of a technician adjusting settings by hand, monitored remotely from Earth through that same relay satellite that had made this entire mission possible in the first place. A tiny, self-contained biosphere, tucked inside a spacecraft, resting on ground more ancient and more hidden than almost anywhere else humans had ever sent living material. And then, remarkably, it worked. Within days of the seeds receiving water and light inside their sealed container, something genuinely extraordinary happened. A cottonseed sprouted, a small green shoot, delicate and completely ordinary in appearance, the kind of thing you might overlook entirely in a backyard garden on Earth, emerged from soil sitting on the far side of the moon. Photographs sent back through that relay satellite showed it clearly. A tiny green sprout, its leaves just beginning to unfurl, growing in complete isolation on a hemisphere that had never, in over 4 billion years of existence, supported a single living thing. Think about what that image actually represents. For the entire span of the moon's existence, stretching back to that violent collision, believed to have formed it, and continuing through billions of years of bombardment, cratering, and eventual gravitational locking with Earth, that hidden hemisphere had remained completely, permanently lifeless. No microbe, no spore, no trace of anything resembling biology had ever existed there. Not once across the moon's entire staggering history. And then, in a small sealed container, barely larger than a shoebox, a single cotton sprout quietly broke that unbroken silence. Here is where the story turns, gently but unmistakably, towards something more somber. That sprout, tiny and fragile, existed in an environment far harsher than anything its systems could indefinitely protect against. Within roughly a week or so of germinating, as the long lunar night began to fall across that hidden landscape, temperatures inside the container eventually dropped low enough that the plant could no longer survive. It withered, quietly, alone, in complete darkness, on ground no human eye had ever directly witnessed, and no human hand would ever touch. There is something quietly moving about that image, isn't there? A single green shoot, growing patiently in isolation, existing for just a few short days on a hemisphere shaped by ancient cosmic violence, silent for billions of years, before fading gently back into that same enduring quiet. Not a failure exactly. The experiment had already proven something remarkable simply by that seed sprouting at all. But a reminder, nonetheless, of just how fragile life truly is when measured against the overwhelming scale and the overwhelming harshness of almost everywhere else in the universe beyond Earth's thin, protective atmosphere. And yet, the achievement itself remained undeniable. For a handful of days in early 2019, a living plant grew, quietly and without fanfare, entirely alone, on the far side of the moon. Farther from any other living thing than perhaps any organism in the history of biology, sprouting on a hemisphere so ancient, so isolated, and so thoroughly unseen throughout human history that its own existence felt almost like a small miracle unfolding in complete silence. No one stood nearby to witness it directly. No camera captured it in real time for anyone watching. It simply happened, quietly, exactly the way so much of this hidden hemisphere's entire history has unfolded, hidden, patient, and almost entirely unseen. This brief, quiet moment of life, amid ancient silence, offered scientists more than just a touching image. It offered real data, genuine insight into how biological systems respond to conditions unlike anything found on Earth. Insight that continues informing plans for future missions and future attempts to establish something more lasting beyond our home planet. But biology was only one part of what Chang'e 4 and the missions that followed it hoped to learn from this hidden terrain. Because buried within the ancient rock and soil surrounding that small, quiet garden lay evidence of something far older, something capable of finally answering questions scientists had been asking about the moon's deep interior for decades. Alongside its small, short-lived garden, Chang'e 4 carried instruments with a very different purpose, not to test whether life could survive on that hidden terrain, but to examine the ground itself, probing beneath the surface to study material that had remained undisturbed since long before anything resembling life existed anywhere in the solar system. Among these instruments was a ground-penetrating radar system, capable of sending signals downward through the lunar soil and reading the faint echoes that bounced back, building a rough picture of what lay hidden beneath the surface without ever needing to dig. Here's the thing most people don't realize about how useful this kind of instrument can be. Digging is slow, difficult, and limited to whatever depth the rover's tools can physically reach. Radar, by contrast, can reveal layers hidden many yards below the surface almost instantly, detecting boundaries between different types of material based on how radar waves reflect differently off rock, dust, and buried structure. Using this technology, scientists studying data from U-22's journey across von Karman crater began piecing together a detailed picture of the layers hidden beneath that ancient, cratered ground. What they found added yet another layer of complexity to the story building around this hidden hemisphere. Beneath the surface, researchers identified multiple distinct layers of material, evidence of repeated volcanic activity that had occurred at different points across the moon's ancient history, each layer representing a separate episode of molten rock rising, spreading, and eventually cooling into solid stone. This was significant because it directly connected the ground Chang'e 4 was exploring to the deeper mystery of why the far side lacked the same widespread volcanic seas so visible on the near side. Think back to that earlier question about why lava rarely broke through the far side's noticeably thicker crust. The data gathered here suggested the answer was not quite as simple as lava never reaching the surface at all. It suggested that volcanic activity did occur here too, but more locally, more intermittently, breaking through in smaller, more limited episodes rather than the widespread flooding that created those enormous, dark seas on the opposite hemisphere. Smaller wounds, filled more modestly, layer by careful layer, across a much longer stretch of time than the more dramatic volcanic history recorded on the near side. Beyond these layered volcanic deposits, researchers also detected something scientists had specifically hoped to find given the crater's connection to that ancient massive impact event. Material with a chemical composition different from typical surface rock, hinting at rock that may have originated from deeper within the moon's mantle, the layer sitting beneath the outer crust, potentially excavated and exposed by the same catastrophic collision responsible for carving out the entire South Pole Aitken Basin billions of years earlier. Here is why that possibility matters so much to scientists studying the moon's deeper structure. Under ordinary circumstances, the moon's mantle sits buried far beneath the surface, completely inaccessible to any rover or lander without deep, expensive drilling operations far beyond current technological capability. But an impact violent enough to gouge out a wound 1,550 miles wide may have done exactly that kind of excavation naturally. bringing deep interior material up to the surface where a rover could study it directly, without ever needing to drill at all. If this interpretation holds true, it means the ground U-22 rolled across, quietly, patiently, across multiple lunar days, may include some of the most direct evidence available anywhere on the moon's surface regarding what lies deep within its interior. Material unchanged for billions of years, undisturbed since that ancient catastrophic impact first exposed it, sitting patiently within reach of a small rover on a hemisphere that remained entirely unseen by human eyes until less than a century ago. And this connects to something even larger than the moon's own history, because the moon and Earth share a common violent origin, believed to have formed from the same ancient collision between the early Earth and a Mars-sized object billions of years ago. Material deep within the moon's mantle may preserve a kind of chemical record relevant not just to the moon's formation, but to the early formation of Earth itself. A record largely erased on our own planet by billions of years of active geology, but potentially still preserved, quietly, within that ancient lunar interior. Consider the strange symmetry in that idea. Earth's own deep history, the conditions present during the earliest, most violent period of its formation, may be better preserved on the far side of the moon than anywhere on Earth's own, constantly shifting, constantly renewing surface. The very isolation that kept this hemisphere hidden from human eyes for the entirety of civilization may be the same isolation that has protected some of the most valuable geological evidence relevant to understanding our own planet's origin. This realization reshaped how many scientists thought about the far side entirely. It was no longer simply a curiosity, an unusual hemisphere worth photographing and mapping out of scientific thoroughness. It had become something closer to an archive, a preserved record of ancient violence and ancient chemistry, sitting patiently, undisturbed, on ground that had waited billions of years for something, anything, capable of finally reading what it had quietly recorded all along. But even with robotic missions like Chang'e 4 gathering this remarkable data, one detail remained strikingly, almost uncomfortably true, regardless of every technological achievement made along the way. No human being had ever stood there. No person had ever felt that ancient dust beneath their own boots, or looked directly with their own eyes at that pale, cratered horizon stretching in every direction. And that fact, quiet and easily overlooked amid so much scientific progress, carried its own kind of weight worth sitting with. Consider for a moment the full scope of human presence on the moon so far. Between 1969 and 1972, 12 astronauts walked across its surface, leaving footprints, planting flags, collecting samples that scientists still study today. Their names are remembered, their missions celebrated, their brief walks across that ancient dust considered among the greatest achievements in human history. And every single one of those footprints, every single one of those 12 astronauts, stood exclusively on the near side. Not one human foot has ever touched the hidden hemisphere. This was not an oversight. It was, once again, a matter of basic necessity, the same communication challenge that kept every uncrewed lander confined to the near side for decades, applying with even greater urgency to any mission carrying human beings. Astronauts require constant contact with mission control, real-time monitoring of life support systems, immediate communication in case something goes wrong. Sending a crewed mission to the far side without a reliable way to maintain that connection was considered too dangerous to seriously attempt during the era when human moon landings actually took place. Here's the thing, most people don't realize about just how thoroughly this has shaped what humanity actually knows about that hidden hemisphere. Every rock sample ever brought back to Earth by human hands, all several hundred pounds of lunar material collected across those 6 successful crewed landings, came exclusively from the near side. Scientists have spent decades studying this material in incredible detail, extracting information about the moon's age, its formation, its geological history. But every single conclusion drawn from that physical evidence describes only half the story. The visible half, the hemisphere humanity has always known. Think about what that means for the ancient wound at the centre of so much of what you have learned tonight. That immense, 4 billion year old impact basin, 1,550 miles wide, potentially exposing material from deep within the moon's interior. No human hand has ever collected a sample directly from its floor. Everything scientists currently understand about it comes from orbital imaging, radar data, and the brief, remarkable, but still limited findings gathered by robotic landers like Chang'e 4. A human geologist standing there directly, examining that ancient rock with trained eyes and careful hands, could potentially answer questions that remote sensing alone still leaves unresolved. And there is something quietly profound in recognizing that gap. For over half a century since humans first walked on the moon, an entire hemisphere of our closest neighbour in space has remained completely beyond human physical experience. Not simply unexplored in the way remote deserts or ocean depths on Earth might be called unexplored, still theoretically within reach for any sufficiently motivated expedition. Genuinely, structurally inaccessible, blocked by the same communication challenge that has shaped nearly every chapter of this hidden hemisphere's story, from its first blurry photograph to its first robotic garden. Imagine for a moment what it would actually feel like to stand there yourself. Complete silence, the kind you learned about earlier, so total that even your own footsteps would produce no sound beyond what travelled directly through your own body. A pale ancient horizon stretching in every direction, cratered and rugged in ways the smoother, more familiar near side rarely matches. And overhead, no Earth, because from anywhere on the far side, our home planet, that comforting blue marble every human being has always been able to look toward from the near side, is never visible. Not once, not from any angle, at any time. That detail alone carries a strange emotional weight worth sitting with. Every human being who has ever stood on the moon, all 12 of those astronauts, could look up during their missions and see Earth hanging steadily in the black sky, a familiar reminder of home, even while standing somewhere so remote. Anyone who eventually stands on the far side will have no such comfort available. Earth will simply not be there, blocked permanently by the very ground beneath their feet, replaced instead by an unfamiliar sky, stars scattered across a darkness, with no blue, cloud-streaked planet anywhere within it. Here's the thing most people don't realise about how deeply that would isolate a person, at least symbolically, even while remaining physically closer to Earth than almost anywhere else in the solar system. Astronauts on the far side would be, in a very real sense, more visually cut off from home than astronauts travelling to Mars millions of miles away, who at least catch occasional glimpses of Earth as a distant point of light. On the lunar far side, the isolation is total and immediate, built directly into the geometry of where you happen to be standing. And yet, despite this profound isolation, plans continue moving forward, slowly, carefully, toward eventually placing human beings there directly. Space agencies around the world have expressed serious interest in eventual crewed missions to the far side, whether to construct that long-imagined radio observatory, to collect samples directly from the South Pole Aitken Basin, or simply to finally close the remaining gap in human experience of our closest neighbour in space. None of these plans have yet moved beyond proposal and early planning stages, but the direction, unmistakably, points toward a future where that final barrier, no human foot has ever touched this ground, will eventually be crossed. And when that day eventually comes, whenever it comes, it will mark something remarkable in the long, quiet story of this hidden hemisphere. Not simply another photograph, another rover, another robotic garden growing briefly before fading into cold and silence, an actual human presence, standing directly on ground that has waited billions of years, patiently, silently, for eyes capable of finally witnessing it in person, rather than through a camera lens, a radar signal, or a photograph transmitted faintly across the emptiness of space. In the years since Chang'e 4 first proved that landing on the far side was genuinely possible, interest in that hidden hemisphere has only continued to grow, spreading well beyond a single space agency into a broader, international conversation about what this remote, silent terrain might eventually offer. China itself has continued building on that initial success, with follow-up missions designed to gather samples and study the region in even greater detail. Other nations, watching this progress closely, have begun drafting their own proposals, each hoping to take advantage of what this hemisphere uniquely provides. Here's the thing most people don't realize about how quickly this kind of momentum tends to build once an initial barrier finally falls. For nearly 60 years, the far side remained purely theoretical as a landing site, discussed in scientific papers and mission proposals, but never actually attempted due to that persistent communication challenge. Once Kuekiao proved a relay satellite could reliably solve that problem, and once Chang'e 4 proved a landing could actually succeed, the far side transformed almost overnight from an impossible destination into a genuinely viable target for future missions, each one building on the technical foundation the last one established. Among the most ambitious proposals currently being seriously discussed is that long-imagined radio observatory, the one specifically designed to take advantage of the far side's near-total isolation from Earth's radio noise. Multiple design concepts have been studied over the past several years, ranging from a single large telescope constructed within a favourable crater to an entire network of smaller antennas spread across a wide area, working together to capture that impossibly faint 21-centimetre signal you learned about earlier, tonight's whisper from the very edge of the universe's own beginning. Think about the scale of ambition involved in even the more modest version of these proposals. Building any kind of radio telescope on Earth requires enormous infrastructure, careful engineering, and constant maintenance. Building one on the far side of the Moon means designing every component to survive extreme temperature swings, operate without direct human supervision, and function reliably for years, using only remote instructions relayed through a satellite station positioned in deep space beyond the Moon itself. Every challenge that made Chang'e 4 difficult would need to be solved again, at a larger scale, for a mission with a far longer intended lifespan. And yet, despite these challenges, momentum continues building steadily, driven by the recognition that this specific opportunity, this exact combination of radio silence and physical shielding, does not exist anywhere else easily reachable in the solar system. Scientists have considered alternative locations, deep space stations positioned far from Earth's radio noise, but none offer the same natural built-in shielding that 2,000 miles of solid lunar rock provides, blocking interference completely rather than merely reducing it through distance alone. Beyond radio astronomy, other proposals envision the far side serving different scientific purposes entirely. Some researchers have suggested it as an ideal location for extremely sensitive instruments studying gravitational waves, ripples in the fabric of space itself, caused by distant cosmic collisions between black holes and neutron stars. Others have proposed using the region for precise measurements of the Moon's own subtle wobbles and shifts, data that could refine our understanding of its interior structure, far beyond what current models, built mostly from near-side observations, currently allow. Here's the thing most people don't realize about why all of this matters beyond pure scientific curiosity. Understanding the far side more completely means understanding the moon as a genuinely whole world, rather than a partially studied one. For the entire span of human history, nearly every conclusion drawn about the moon relied on data gathered from a single hemisphere, the one always facing us. Only in the last several decades, and especially in the years since Chang'e 4's landing, has that balance finally begun to shift, however slowly, towards something closer to a genuinely complete picture. And there is a broader significance here too, one that reaches beyond the moon itself. Everything scientists learn about building instruments, sustaining biological experiments, and establishing reliable communication across this uniquely isolated hemisphere directly informs plans for future missions much farther from Earth. Mars, the moons of Jupiter and Saturn. Any future mission to a genuinely distant world will face communication and isolation challenges even more severe than anything the lunar far side presents. In many ways, this hidden hemisphere has quietly become something like a proving ground, a nearby laboratory for testing the kind of technology and thinking humanity will eventually need much farther from home. Think about that role for a moment, considering everything you've learned across this journey tonight. A hemisphere shaped by ancient, catastrophic violence, hidden from human eyes for the entire span of civilization by nothing more than the quiet mathematics of gravity. Silent in ways almost impossible to fully imagine, both acoustically and electronically. Home, however briefly, to the first living plant ever grown on another world. And now, quietly, becoming a stepping stone toward humanity's next great ventures beyond Earth entirely. None of these future missions have fully arrived yet. The radio observatory remains a proposal. Crude missions to that hidden terrain remain years, perhaps decades, away from actually happening. But the direction is unmistakable, building steadily on each small success that came before it, moving toward a future where that hidden hemisphere becomes not simply a mystery finally photographed or a landing site finally reached, but a genuine, active frontier for what comes next in humanity's long, patient relationship with the universe beyond our own world. So let's come back gently to where we began tonight, to that single familiar face, the one you have looked up at your entire life, the one every generation before you looked up at as well, stretching back through the entire span of human memory. That face never changed. It never turned. It simply waited there, patient and constant, exactly as gravity arranged it billions of years ago, long before anyone existed to notice or to wonder what might be hidden on the other side. And now you know. Now you carry quietly the knowledge that an entire second world exists just beyond that familiar light, close enough to touch with a good telescope, and yet forever turned away. A hemisphere shaped by a catastrophe so immense, it very nearly reshaped the moon entirely. A landscape thick with ancient highlands instead of smooth dark seas, its very structure hinting, perhaps, at another moon entirely, absorbed long ago into the one you have always known. A silence so complete that even footsteps would vanish the instant they occurred, and a stillness so absolute it remains one of the last truly quiet places anywhere near Earth. Think about what it means that something this close could remain unknown for so long. Not distant, not buried behind clouds of gas or the edge of the solar system. Right there, the whole time, turned quietly away by nothing more than the patient mathematics of gravity. There is something almost comforting in that thought, isn't there? That mystery does not always require distance. Sometimes it simply requires a different angle, a little more patience, and eyes finally capable of looking where no one had looked before. Here's the thing, most people don't realize about why this story matters beyond the moon itself. Every discovery you have heard about tonight, the first blurry photograph, the ancient impact basin, the fragile seedling, the proposed observatory listening for the universe's very first whisper, each one required someone willing to reach toward the unknown, patiently, methodically, without any guarantee of what they might find. That is not simply the story of a hidden hemisphere. That is the story of curiosity itself, quiet and persistent, capable of eventually illuminating even the parts of existence that seemed permanently out of reach. And perhaps that is the deeper truth resting beneath everything you have learned tonight. We are, each of us, a little like that hidden hemisphere ourselves, carrying entire landscapes within us that others rarely see, shaped by our own quiet histories, our own ancient impacts, our own long periods of silence between moments of unexpected growth. And just as that moon required patience and the right instruments and the willingness to look from an entirely new angle before finally revealing itself, perhaps the truest parts of anyone and anything become visible only when someone is willing to wait long enough, gently enough, to see them clearly. We are the universe noticing itself. That is what all of this amounts to in the end. Atoms forged inside ancient stars, arranged by time and chance into something capable of building spacecraft, launching relay satellites, and reaching toward a hidden hemisphere just to finally understand what waited there in silence. The moon did not need us to exist in order to be real, but it needed us, eventually, to be truly seen, truly known in all its ancient, cratered, and quietly violent history. And somewhere right now, that same hidden hemisphere continues its silent, unseen existence exactly as it has for billions of years. No wind moves across its ancient highlands. No sound travels across its cratered plains. It simply waits there, turned permanently away, patient in a way that feels almost impossible for anything living to fully understand. And yet, because of everything you now know, it feels a little less hidden than it did when we began this journey together tonight. Thank you for spending this quiet time with me tonight, drifting through the story of a hemisphere that waited billions of years simply to finally be seen. If you found comfort in this journey, in the gentle strangeness of a hidden moon and the ancient silence written into its ancient scars, consider leaving a like or subscribing so more curious minds like yours can drift into these same quiet mysteries. It costs you nothing, and it helps this small corner of contemplative space keep growing. And so, as you settle now into the stillness of your own night, let your thoughts rest gently on that hidden hemisphere, turned quietly away above you, ancient and silent, patient in the dark. The next time you look up at the night sky and find that familiar, comforting face looking back at you, remember what waits just beyond it, unseen but no longer unknown. Sleep well tonight and keep looking up at the stars. Good night.